All attendees are in listen-only mode.
Hey folks, welcome to Webinar Wednesdays. This is the second Wednesday of the month, and that means it is time for some AI stuff. Bit different today. Rather than give you a prepared PowerPoint, because I ain't got a prepared PowerPoint, I thought what we would do is I've got some kind of example Unity projects and some ideas that I think that I would like to show you, and from there we can kind of have a talk about what I'm doing with this stuff and kind of the AI behind it and how it all works. So it's a little bit 101 kind of stuff, but a bit more kind of technical and hands-on than we've been doing for the past couple of months. So theoretically, you should be able to see my screen, which is showing Unity just now. And if we hit play, what I'm going to show you, in fact, I'm just going to turn that off and give you that for now. Oh, that didn't. Oh, okay. If I turn that off and set all the values that I need to set, and then show it you. Okay. Off to a cracking start. All right. Got it this time. Third time's the charm. Here we go. So what we've got here is we're generating landscapes, and we're procedurally generating a level right here. And as you can see, it's not a very well-designed level, and it's not very sophisticated. It's just plopping cubes down. And if I bring up the script for that, which is going to open on the other window, on the other screen. So if you give me 2 seconds while it loads up. But as you can see, it's kind of, as the name suggests, it's a random generation. And this is what it looks like. So you set up the length of the X and the length of the Y here, which are ints, and that gives you basically the bounding of how big a square you're going to do. And the size of the blocks tells you how far along you're going to move every time. And this is the max depth is telling you how many you can stack maximally. And then what you do basically is you just step across it and generate a random number here, and basically just throw as many blocks into that column as you need for to meet the random number, and then move to the next square and make as many blocks there to generate the column. Dead simple, very easy stuff. However, what you'll notice is that it kind of looks like shit. You know, it's very kind of disorganized, and it's fairly clear that it's very, very noisy, very random. So we don't like doing that, and I would say arguably that that's kind of not AI. So if you kind of look at this thing and see this, there's no real decision being made. And if you attended the session 2 months ago, the first one that we did, we talked about AI being the science of decision making and the applied science of decision making. And there's not really a decision been made here. Arguably, how many blocks to put in each column is kind of a decision, but not really. So let's do something a little bit more sophisticated. So we're going to turn the random script off, and we're going to turn this one on. Right? If we generate that, straight away you can kind of see that there's more order to it, and there's more kind of structure to this world. There's hills, and the hills are kind of more clearly defined, and you can see that there's kind of a valley here coming around. All we've done here is implemented a system of what's called Perlin Noise. So you can find pretty detailed implementations on kind of how Perlin Noise works on the internet. But effectively what we do is we take a whole bunch of mathematical functions. In fact, while I'm talking to you, I'm just going to see if I can pull up a diagram showing it. So we take a kind of a bunch of these mathematical functions and piecewise put them together. And that kind of allows us to produce a very kind of noisy but well-behaved kind of function. And we can, instead of generating a random number, we can evaluate this function. And from there, actually, so this is a good example here, these diagrams. So what you see is that this one kind of has a specific kind of random kind of structure to this function. And this one is the same thing, but changed a little bit. And again, you combine all of these with different frequencies, and you'll see that the peaks and the troughs of each one are slightly different, and the frequency values are here. And at the end of it, what you get is this kind of very noisy but controlled noise kind of function. This is typically used in this kind of text generation. So you can see here that there's this kind of very high frequency noise, very low frequency noise, very kind of very dense, and over here there's a very kind of very staticky pattern. And again, you combine all of this from the start to the end, and you come out with this here, which is actually a really nice looking texture, but it's mathematically generated, and that's a really interesting kind of a way of doing that on the fly. And I would actually recommend this URL right here as a really good intro to this. But like I say, we've got the implementation of that right here. And basically what we do is we generate the noise function, and then we evaluate the noise function. And we do that because of the way it works, we actually need to have a predefined set of values. So here's a bunch. I believe these need to be prime numbers, but maybe not. But anyway, you need a bunch of numbers, so they're there, and you draw from them here at random, and you just step through it, calculate the noise value for that particular X and Y, and then step through and kind of build up the columns as you did in the original random number generator, random terrain generator. So that's giving you that kind of well-behaved terrain. I'm not going to say for sure this is how Minecraft implements it. It would surprise me if it wasn't something similar to this. And Perlin Noise is actually used for a whole bunch of stuff. One really good demo of it, if I can just find it. I don't see it on these Google results. But one thing that you can do with it is that you can use it for idle animations. And what you can do with that is you can kind of use Perlin Noise to guide maybe where a character's eyes are looking, or where their head is turned. And over time you can kind of vary it, not at random, because if you're at random then it's just going to kind of look all over the place and not look particularly sophisticated. But if you use something like a function like this, you can see that it changes, but it changes over time and it changes gradually, but it changes at random. And if you use that kind of, if you imagine that this graph here is a 2D graph, or even just imagine it controlling one axis of where your eyes are looking, then you can kind of see that the character here is looking kind of down the middle, and then maybe a little bit to the right, a little bit to the left, very shifty-eyed here, and then it tracks to the right. So you can use that to actually kind of add more kind of animation to what the character is seeing and how that's all behaving. Same thing with tracking like aim for a character shooting. An NPC will always be able to draw a line from himself or herself to the player and shoot down that line. Well, that doesn't make for an interesting game. That's what we were talking about 2 months ago with this kind of idea of being a good dad and kind of offering challenge, but beatable challenge. the NPC can shoot the player directly in the headshot every time. It's more interesting to add noise into that and make it believable. So, you know, having this idea of Perlin Noise built into the aim thing, where it's going to kind of sweep a little bit left, a little bit right, wave around, but not at random, and kind of having a very kind of well-behaved but random-ish kind of approach. So we've used it here for kind of a height generation and just determining how many blocks we're going to put into the world. What I want to show you just now, though, is a different project. And this was a play about heading towards a 2D RPG that I didn't really go anywhere with. So if I open up the scene, so straight away you'll see that this is kind of a bit of a similar idea in that it's a 2D tile map, top down, and if you can, well, as you move, you'll see that you're controlling the kind of the red character, and the blue character is moving as you move. So it's kind of a turn-based thing. Again, this is being generated by Perlin Noise, and instead of the number of blocks high we put into the world for each value of the Perlin Noise that comes out, what we're actually going to do is over here we have an array of elements: water, gravel, grass, dark grass, mud, and rock, and I've organized them in what I feel would be like a ascending height kind of approach. And what this allows me to do is at the bottom, at the lowest point of the terrain, if you think about it as a cross section, at the lowest point you'll have your water here. So, you know, this is all water. You're getting the high-tech drawings now. And then, was the sand in this one? No, gravel was next. Okay, so then you get your gravel, and that's kind of your beach kind of stuff. You know, and you're building it up layer after layer to kind of then going up here. You would have your hills, and then at the top of the hill you have your very kind of hard rocks, and there's two different tiers of grass in the middle. So I mean, very simple, very straightforward, but actually quite easy. You know, you can put a script together like this in maybe an hour, and then again you can just sort of kick out these terrains. And the nice thing about this is that you can then say, okay, well actually the heavy rocks are impassable. So if you try to traverse to where they are, you can't do it now. I've not implemented that in this, but it's easy to see how you would implement it if you look at the script for this one. So again, it's very, in fact, I think it's actually the same code base as what I showed you previously, but you're instead of instantiating a number of tiles, what you're doing is you're actually instantiating a specific tile and just laying that flat on the ground as a color. And if you look at how that's structured, what you'll see is that there is actually an array of game objects, but that's the public side of things. But privately, there's a 2D map here, and then we have over here we have the character controller. If you're going to go down, then move the dude and tell the other guy to take its turn. And it would be very simple here to test whether that was actually a passable terrain or not by asking that map if it is one of those dark rocks. So stuff like that you can do very simply, very straightforward, and it's very easy to do. But what you've done there by using a script like that is you've got these procedurally well-behaved levels, and then you can actually tweak how they behave. So if we change this here, now it's been a while since I've messed with this, so wait, hang on. No, that's not going to work. Right. It would be very simple to change the tone of the space. In fact, that's why I have the other code base. Just give me 2 seconds and I'll swap over to the other project and I'll show you that. So here we have the Perlin Noise and we have the number of octaves that we're going to put on it. So we could actually drop that down to 2, and that's going to give us a very different kind of feel to the space. You see how it's actually immediately quite a lot more noisy, whereas if we raise it to 10, then you can see that that's changing the tone quite a bit. And again, you can change kind of the depth of stuff. And I need to stop making these changes while Unity is playing the game. But it's very easy then to control the space that you're creating. So that's kind of a very quick and dirty approach to kind of procedural generation. But you can do more interesting things with that. So you can move on. So I'm going to show you something that I'm actually working on commercially just now. No. So this is a mobile game that I'm working on, and I'll show you the main loop of the thing. So over here, what we have is a completely procedural maze, and we're laying that maze out in a very different way to what I was showing you previously. But we had those ideas of like bands in a Perlin noise generation. So what we can do is we can take that kind of strata kind of approach that we saw here, and we can apply that to a game like this, where we have different areas having different textures and different tones, maybe different color schemes. So as you can see from the game world here, we're dealing with kind of a brown, kind of rocky kind of formation. And using Perlin Noise, and we've not implemented it here yet, but we've sort of got vague plans to. But using Perlin Noise, what we can do is we can transition from that rocky kind of area to maybe an outdoors area, or maybe a different kind of feel to the rocks. And we can structure it in such a way that what we kind of create are what we call biomes. And a biome is like an environmental kind of term for a specific kind of environment. So these are a little bit different. But basically what you're doing is you're generating spaces that have a certain tone, and then using different parameters to generate a different kind of tone. All you need to do in order to make that happen is to put a Perlin noise generator in front of what you're doing on the maze generation. So our maze generator right now, I'll not show you the code for it because it is ugly as hell. But effectively all we do is we have a whole bunch of prefabs, and we kind of instantiate each one, or we instantiate a one from this list, and then we carry on. It would be very easy to kind of create a set of these and just make them as sets. So various, these are all the slope ones, apart from the ones that we've not fixed yet. But you have a bunch of slopey ones, and then you have a separate array or an array of an array that has a different kind of thing. And all you do is you get your Perlin evaluator up front to choose which set you're going to choose from, and then go on and lay them out. And again, this isn't rocket science, but just knowing that you've got these tools at your disposal is really a powerful way that you can kind of not just do your procedural content, but also do procedural in a way that is actually really kind of nuanced and nice. So moving on from this kind of idea of procedural level generation, So what I want to show you now is, so if you look here, as we're moving through the game world, you'll see that there's this upright structure, and it is actually facing the wrong way. It's 90 degrees out. So that should be over as a support for this gold mine sitting across the passageway. So what we can do is we can go in and fix that, because what our system does is it's got this kind of idea that every pickup, power-up, and prop within this world is independent of the actual prefab level piece. So we have an ability to kind of position these wherever we want them and do that on the fly. And the way that we do that is through what we call hotspots. So if I bring in this prefab. So we've got this prefab here, which is just the kind of level geometry for what that piece looks like. And then we've got this thing called a support spot. And as you'll see here, it's set to have the support east-west slope. Well, I can tell you now that passageway runs north-south, so what we should actually have is the support north-south slope. So we'll make that change, and we'll store that back into the prefab, and we'll delete that from the game mode. We'll play again, and as you can see straight away, by making that change, it's now picking up the right element and putting that in the right position. So that's really straightforward. But what if we want it to be something else? Well, if we jump over to this window here, so this is where 2 months ago I kind of talked about how AI developers are really kind of tools programmers. What you'll see here is that we have this thing called the north-south slope, which is what I just picked as the thing that we wanted to designate as happening in that game world. And here is a list of all the things that we might instantiate on one of these hotspots. And you can see that there's a 76% chance of instantiating that support that you just saw. There's an 18% chance of instantiating a slightly different version, and that means that there's a 5% chance of instantiating nothing. And like I say, a big portion of what we do is tools programming. So we've got this procedural system, but we've actually put it together in such a way that our game designer can just sit down and play about with us and never has to go near the code. And that is a really big thing, because the code for this is ugly as hell. If I jump over to the inspector and show you the maze builder routine, which I think I said I wasn't going to do, but oh well, let's do it. I'm not going to walk you through it because it's ridiculously long and ugly and complicated, but I mean, you just don't want your designer coming anywhere near this stuff. It takes me a minute to work out where the hell it all happens, and particularly for placing the deployables, that happens in this routine here, which is here. So I mean, there's this kind of stepping across. For each object in the maze, we find the maze piece, and we find the deployable spots within the children of the maze piece, and we kind of instantiate based on that. You just don't want your designer going near that kind of routine. So we give them this, and what this means is that we can control that they kind of say, okay, well, we actually want that to happen all the time, or we want always the support north-south. Or we can, right here, we can say, okay, well, actually, let's spawn some TNTs, always spawn a TNT on there. And the way that it's working for us right now is that we're using this nice front end as an overlay over pars. So all of this data then gets serialized out and written into pars if you click the update button. So that's gone now. And as soon as we start up, I think it might actually take 2 plays to come through. That's just to do with how we're decoupling our local cache from pars. There you go, straight away, there's your TNT, and obviously touching that, bad news, game over. But we've been able to adjust that on the fly without having to touch the code, without having to touch, we have recompiled the game, but we wouldn't actually need to recompile the game. Just changing that value would push it to the live game. So yeah, so this is kind of a direct example of how you can build these fancy kind of routines and systems, but at the end of the day, you need to make them accessible and you need to make them usable. So I mean, it's very straightforward now for our designer to kind of come in and oh yeah, okay, it disables everything while we're in play mode. But now our designer can come in and say, well, actually, stop messing with my values because I've got the right ones. And it was I don't know, those are close enough. So I'll update that to pars, and that's reset what we've just messed about with there. And again, 2 plays through. So the first time we'll have the TNTs picked up. Second playthrough. There's the 3-legged support. So that is the sort of, well, it's now a 12% chance. But like I say, I mean, sort of, we're now moving towards having a very kind of polished, designer-friendly procedural system where not only can we have kind of procedural mazes, but we can have different textures and tones to those mazes that make sense. I mean, if you go to the bother of creating a transition into an outside kind of space in your maze, or even a big cavern, then you don't want to transition immediately back, and that's what random kind of puts you at risk of. So you need to move away from random, and you need to move to something a little bit more complicated, and Perlin Noise is kind of the thing for that. So what else can I show you? Well, so I can tell you a little bit, I guess, about what we're trying to do with this game. So the eagle-eyed amongst you might have spotted that we have a game analytics integration and pars integration. What we're trying to do here is, if you look in, so we have this. This is kind of the older system, but we have this idea of a difficulty system. And what this does is it kind of changes the tone of the space, and it changes how many TNTs you're likely to face, and as the game kind of progresses through the levels, it becomes progressively harder. Pretty standard. That's kind of the way, the accepted way that games work is later levels are harder. But the question is harder necessarily a good thing? At the end of the day, like, hard means different things to different people, and having a fixed difficulty progression is generally considered bad. It's not really the right way of doing things. For example, consider, well, just consider like 2 different people with very different kind of skill levels. If you have a fixed difficulty system, then you are not accounting for maybe their different progression, their different kind of learning of the expertise of the game, and also their different starting abilities. So intuitively, we kind of can see that adaptive difficulty is kind of the way forward, where we kind of say, okay, well, let's try to match the difficulty of the game to your skill level. But the big question is, like, is that actually what we want to do? And I mean, this kind of is something that I'm pretty kind of hot about, because I play a lot. I mean, I think most gamers play a lot of first-person shooters these days, because that's a lot of what games companies are putting out. But like, I want to, like a game like Halo, if I'm playing the single-player campaign, I don't necessarily want an adaptive difficulty system, because at the end of the day, I want to experience the story, and I want to kind of tour the content and see what the game and the world and everything that's been put there is about. And that means that my particular playstyle is I tend to play on a lower difficulty than my skill level is necessarily for. Now, if you say that, okay, well, you know, in terms of adaptive difficulty, we're going to adapt it, and we want to set the bar at, you know, this level takes you maybe 5 goes to actually figure out how you're going to go. So you're going to die 4 or 5 times, and that's, you know, regardless of your skill level, we're going to set the bar at, we want you to take about 5 goes round, and then we'll kind of, you know, we'll space out where the enemies are if you're a bad player, but not to a point where you just kind of walk through it and you'll die 5 times, or we'll throw a whole bunch of stuff at you and you'll still die 5 times, because that kind of levels the playing field. But the assumption that you've made there is that you can decide how frustrated the player wants to be with this level, effectively. And that's why sort of a very sort of naive approach to adaptive difficulty is really kind of bad. I don't want to be frustrated at all. I play games for amusement. I really don't want a challenge. Whereas people, I mean, if you look at a game like Dark Souls, those guys really want a challenge. They want to earn their progression. They want to kind of have that very hard problem to solve, and solve it, you know, with that feeling of accomplishment at the end. So if you start monkeying about with a difficulty based purely on skill, that's not necessarily the right thing. So, I mean, then you can move to a thing like a two-dimensional thing. Well, okay, what's your skill level and how challenged do you want to be? And, I mean, maybe that is sufficient. I'm pretty convinced that even then there's more nuance to kind of how and why we play games that isn't being accounted for. So what I really want to move towards is not just a difficulty progression, but a whole kind of design tailoring approach based on player profiling. And this is kind of the big thing that we're trying to build into Easy Money, which is kind of analytics and analysis on the back end to kind of work out the ways in which you play the game, and then tailor the game to suit those ways. And I think this is not necessarily a well-understood kind of area right now. I think it's probably one of the things that's going to be kind of the future of where we're going to go. But at the same time, like, it's still mildly possible. So what you can do, even very quickly, is you can kind of start logging a lot of stuff with game analytics. You can integrate game analytics into Unity in about 10 minutes. It is a really nice little bit of kit. And the one piece of advice that I do have is if you can find stuff like this that will do logging for you, just use it. So what I want to show you is objects, resources, deployables, TNTs. So in the inspector, what you'll see is that we have an on-trigger enter for this, and the same, I think, for the golden nugget, or maybe this one. Yeah, so we have these bound to the on-trigger enter, and what this allows us to do is when the player object collides with these elements, it logs that into the game analytics. And we've also got other data getting logged into game analytics and into parse. That gives us kind of this idea of data points where we can start analyzing your play and start kind of building up a profile of the way you play. And the long-term objective of that is, because everything in Easy Money is procedural, is that we can start feeding that back in. And kind of the most obvious, lowest hanging fruit kind of way that we implement this is to say, okay, it's two very different kinds of, so Easy Money, as you saw, is this maze game with a ball. What you're probably not aware of is that the idea is that it's on mobile using the tilt sensor rather than I was using arrow keys because I don't have a tilt sensor on my desktop. And the thing here is that we feel like there's probably going to be at least two different play styles, and one will be a very kind of methodical, very paced kind of way of playing the game, very explorative, kind of looking around the maze, finding everything there is to find. And then we'll also have kind of more action-oriented players who will be kind of ninjaing through the level effectively, and whipping around these hazards, and not necessarily giving the hazards a very wide berth, which the more kind of steady and sedate players might do. And if we can identify those different types of play from analysis of the data and analysis of the playthrough telemetry that we're getting, then what we can do is we can actually start customizing those spaces, and we can say, okay, we're going to give you a very more kind of sedate level. We're going to give you things to find out on the edges of the maze, so that you get that sense of reward that you're kind of looking for with your playstyle. Similarly, for the more action-oriented player, you can actually give them a lot more kind of things to avoid, and give them those kind of epic moments that they seem like they're looking for in the way that they're approaching the gameplay. Procedural gets us the ability to do that because, like, we don't have handcrafted content. We can adapt it on the fly, and we can fit it around kind of the way that they want to do stuff. And that is kind of that's sort of where we're heading, and that's our long-term vision of what we want to see happen with procedural. I think we've been designing games that are one-size-fits-all for far too long, because at the end of the day, we're not all one kind of player. I have a very different play style to a lot of people, and they have different play styles to we play games differently. I was playing Left 4 Dead maybe a year ago with a friend who was a Call of Duty player, and that was his game. That was every Call of Duty game came out, he would buy it, he would sit with his PlayStation and just play it over and over and over. So we sit down to play Left 4 Dead, and I'm sort of very much a sort of cautious, let's move up, hide behind here, is there anything around? Whereas he's running around throwing grenades around, just kind of shooting anything that moves, because that's kind of the play style that he's brought from his gaming history. And neither of them are necessarily, I mean, they match or don't match the way that designers intended that game to be, but at the same time, that's not necessarily right or wrong. And if you can give somebody a way of playing your game in the way that they want to play the game, then that's probably a really good thing. And again, that kind of automated decision making, that is purely an AI thing. And that is kind of, it's about empowering the machine to make those decisions on our behalf with guidance and with kind of information about, okay, well, this is what this kind of player looks like, this is what that kind of player looks like. But you as the machine decide which one they fit into, and then start adapting things in the way we've told you to do it. Because we can't look over every player's shoulder, and we can't kind of tailor the content, and we can't make games for individuals. And AI kind of allows us to cheat and make AI games for individuals without actually meaning to. So I guess I'm coming in for a bit of a landing to allow a bit of time for questions. I hope that that's been a little bit insightful. Like I say, I didn't actually have anything prepared for this, so kind of an off-the-cuff walk through what I'm working on just now. So I'll just put my contact info here because it would be at the end of my presentation if I had one, but I don't. So you can get in touch with me, Luke at IGDA.org. You can find my website, which I don't keep up to date, at LukeDicken.com. You can find me on Twitter. That's where I tend to hang out, is at LukeD. And I will also tell you that if you have feedback, suggestions, or anything else for the webinars, for the Wednesday sessions from the IGDA, you can get that at webinars@igda.org and send us your thoughts. So if there are questions, now would be a good time to start asking them. Equally, now would be a good time for me to have a window that I can actually read. Okay, so code examples. Yeah, I'm reasonably happy to give you the code from the Perlin Noise from the terrain generator. It's not a very sophisticated project, but it can kind of give you a start heading down there. Obviously, the commercial stuff that I'm working on, that's not. I can't share that, even though I kind of gave you a quick look inside a bit of it. Ben asked, what about adaptive AI on a racing simulator, though? And that's a reasonable question. I'm not a racing guy. Excuse me while I cough up a lung. But I mean, if you look at something like the drivatar system that Forza has implemented, what they're doing is kind of it's a similar. Well, so I'll tell you about drivatar, and then we'll talk about the way that the adaptive stuff can work with that. So drivatar effectively analyzes your play and tries to replicate that. And back in the old Forza days, the point of that was that effectively they had like a championship kind of mode. And if I say it started to drag a bit, it sounds unfair because it's not my genre of game, and that's sort of judgmental on my part. There were a lot of races that you could take part in, and you could sit and play each one yourself. But one of the kind of hooks was that you could kind of train this system on how you drive, and then from there you could let it play for you, and it kind of simulated it out very quickly. Under the hood, allegedly, what it was doing was it was kind of building up a neural net that was kind of looking at how you play the game and trying to adapt to that and trying to kind of mirror the way that you play the game. So that was kind of in the dark ages in maybe Forza 1 or 2, something like that. And I mean, Microsoft have kind of trotted out the drivatar recently as this all new, all singing, all dancing thing. It's something that the tech behind it has been around for a very long time. And I'm not to take away from them. I mean, it's their tech. They've had it for a very long time. But at the same time, I mean, the big thing with the latest kind of drivatar is that they could upload that kind of that reference data to the cloud, and that would allow you as a player to download it later and play against your friends even though they were doing something else, and it would still have the same kind of play as your friend or whoever it was. So that was somewhat compelling, but in a way that's still kind of not getting towards adaptive. I mean, there are ways that you can adapt NPCs in order to kind of allow you to win. The very kind of obvious and naive way of doing this is obviously rubber banding. So rubber banding is basically the further away you are from the player character, or the player car, I guess, in this example, sort of the slower you go, effectively. Or sort of the further in front you are. So basically it means that the guys at the front kind of get held back and the ones at the back kind of get pulled more up. I think probably the most obvious kind of rubber banding that you'll see is probably in Mario Kart. I can't speak to the new one, but certainly that's been my experience, is that the older ones were a little bit kind of blatant in the way that they did that. But it is a kind of established trick in that, like, it works in kind of slowing down the NPCs so that you can kind of get past them even though you crap is actually a justifiable and legitimate technique. It's not very subtle, though. And a more kind of subtle approach might be to kind of at the end of the day, what you have to do is you do have to slow people down, right? But rubber banding without justification just means that you kind of slow down. And a lot of it is about kind of, and this is something that we kind of touched on 2 months ago, justifications and allowing the player to construct a narrative for why that is happening. So, you know, if you had a game where you had one car very far in front, and suddenly they just slow down. Well, that is kind of narratively, there's no justification for that. Now, if you have a car very far in front and he, off screen drives into a wall and, there's kind of a big explosion and all the rest, that is something that, like, as you kind of drive past his smoking wreck or whatever, as a human, you're going to construct a narrative around what happened there. And if it's the guy in front, the narrative is probably going to go something along the lines of, tortoise in the hare, and this guy was pushing it too hard, and he was trying to do too much, and he ran into a wall, and it serves him right, effectively. And just in that one little change, rather than slowing the guy down, causing some justification for that slowdown, has given us a situation where the player is more likely to believe it. So there are probably, for people who are kind of proficient in racing AI and even racing games, because I don't really know what I'm talking about, I'm just kind of waffling here. There are probably better and more kind of nuanced ways of doing that. But that's kind of the overarching kind of way that I would suggest implementing adaptive AI in a racing simulator. But like I say, I don't really know what I'm talking about. The guy to talk to for racing AI is a guy called Andrew Frey, and he's on the list of people that I'm probably going to hassle to try to get a webinar out of him. So stay tuned, and we might hopefully have some racing-specific stuff later. Do we have any other questions? Doesn't look like it. Okay. Last call for any more questions. Oh, hang on. Or so you can type your questions into the questions box, I think. I probably should have said that before I started asking for questions. Or there is a little raise hand button somewhere, and if you've got a microphone, you can put your hand up and I can let you speak. Okay, we have a hand up. Juan, could you please ask your question? Oh, okay, Juan has typed his question. So Juan has asked, I'm a newbie, could you recommend a bibliography? Yes, and also no. So there's a few places you can hang out and find a lot of stuff. Obviously, there's gamedev.net. There is always, well, I say always, there's regularly an interesting AI article pops up on gamedev.net. The big place that you get kind of information on this stuff is aigamedev.com. So Alex does a relatively good job. I tend to find that aigamedev.com is less gentle to newbie stuff and kind of dives in straight away. But if you can get up to speed, that's a really good place. There is a bunch of books. The one that I'm working on right now is this one. So this is AI Game Engine Programming by Brian Schwab, who did last month's webinar. As you can see, that is a thick book, and it is not sort of big typeface. It is detailed, and it has everything that you kind of need from start to finish. So there is that. There is also Game AI Pro. So this is the new book in the Game AI Wisdom series, and this is more kind of, it's not quite as newbie friendly, but it's very detailed dives on techniques that have been used in recent games. There is also This one, Unity 4.x Game AI Programming. Do not touch this book. If you see a copy of this book, set fire to it. It is not worth buying. So those are my recommendations. So you've got a couple of websites you can check out for free, a couple of books. You can dig through the altdevblogaday.com archives. In fact, I should write all of this down. So I will add this to my thing. So we have Game AI Pro. We have AI Game Engine Programming. We have AIGameDev.com, GameDev.net, and another place to look would be to try and search on the Gamasutra blogs, and see. There'll be a lot of information on the Gamasutra blogs. It will be a little bit harder to find without kind of knowing the keyword that you're looking for. Like if you're looking for some information on behavior trees, it's there, and if you know that you're looking for information on behavior trees, you can find it. If you want to know about AI, then it's a little bit harder to get information out of Gamasutra. But hopefully that answers that and is also helpful to a few people. So unless there's anybody else with a question, I think we're going to call it a day there. I see no more questions. Okay. Well, thank you very much for turning out. I hope you found that useful. I'll work with Tristan to figure out where we're going to put that code sample. And if you have any questions for me in the meantime, you can always find me, like I said, on Twitter or email me, or I'm relatively easy to get hold of usually. So thanks for coming. And next week is, I want to say it's game design, but I am not sure, so I will look it up in a separate window. So yeah, we're going to be talking game design next week, and that is going to be a Q&A with game designer Adam Thompson of FirstEarthGame.com. So make sure you register for that if you're interested in it, and otherwise I'll probably see you next month for our August AI seminar. Cheers.